Okay, hello everyone. It is time to move on to the next lecture. I am Shinji HASEGAWA from Waseda University, and I will be moderating this session. It is my great pleasure to introduce you to our special guest, Thierry MAYER. Mr. MAYER is a professor of economics at the Institute of Political Sciences in Paris, often referred to as Sciences Po, one of the most prestigious grandes écoles, which is a elite education system quite unique to France. He specializes in international trade, FDI, location of M&E, or economic geography. Professor MAYER is one of the most prominent economists in France, and he has published many articles in leading journals, such as Journal of International Economics, Quarterly Journal of Economics, Econometrica, American Economic Review, and so on. And he is known worldwide as the most highly cited scholar in the field of international economics. We have invited him today since he is exactly the right person to talk about GVC's global value chains, the main topic of this conference. And despite the 8-hour time difference between Tokyo and Paris, I guess it is now 9 a.m. there. He has kindly agreed to speak. Please note that today's event is a webinar and the audience will not be able to speak directly into the microphone. So if you have any questions or comments, please send them using the chat. You could also use the Q&A function available, but it is quite complicated, so please use chat instead. Professor MAYER will make a speech for half an hour or so, and he will answer your questions as time permits. We have also organized a free discussion slot after Professor Buckley's talk to follow. MAYER will be there to answer any remaining questions and to discuss with Buckley and others. We have just sent his presentation slides to all the audience via chat, so please check them out. Now, Thierry, I will give you the camera and microphone. C'est à toi, Thierry. Merci.
Thanks a lot, Shinji. Very happy to be here, despite the time difference. I'll be even happier in Japan, but probably next time we'll be back in presence. So I'll be presenting a joint paper with Keith Head and Mark Millett, titled "Moving Parts." It's a particular application of a value chain exercise, both theory and empirics, applied to the car industry, where those value chains are probably the most elaborated, complicated, and also happens to be that there's a lot of policy interest. So the specific topic of interest of this paper is to apply a value chains approach in terms of the economics behind it to a policy question about the rules of origins. Those contents rule, the rules of origins it's going to be the first part of my talk. I'm gonna actually show you a theory result. I'm going to go quite fast about that to have enough time for the data. I'm going to talk to you about engine and transmission sourcing and also assembly sourcing in the car industry, and show you the results and show you a very, very first pass at counterfactual analysis, looking at change in the rules of origins. So rules of origins are needed in some kind of rules of origin or any free trade agreement. Those rules of origins usually, and I'm gonna actually talk about this percentage term quite a lot, are usually spelled out in terms of percentage. So NAFTA ended up having a 62.5% content rule for automobiles. It used to be 50% in the US-Canada auto pact. So it means that 62.5% of anything that is sold in NAFTA, in order to qualify for the zero, so a car exported from Canada or Mexico to the US, to take the most prominent example, must have 62.5% of its content, of its cost, actually made in NAFTA. The motivation for this paper originally was that the new NAFTA 2, in a sense, was imposed by Donald Trump and beefed up that 62.5% to 75%. Okay, and so we were asking ourselves, first, what is going to be the consequence of that, and second, is there an optimal rule of origin in terms of attracting firms, which is obviously the raison d'être, as we say in French, of those rules of origins. So I'm going to talk about the theory just now, and then we're going to have an application of this theory, or it's not directly linked, but it's pretty linked to the global sourcing of the auto parts and an assembled vehicle. And then we're gonna try to have the first pass at the cost penalty of compliance with structural rules of origins. When you go from 50% to 60%, or when you do it from 60 to 75%, what does it change? So the model, in terms directly in it, and I'm going to mostly show you two or three graphs, but I need to just set up the scene first. So think about a production process where you got a continuum of parts. They can be produced at home, H, or they can be produced abroad at a certain cost, CI of X. Okay, so each of those parts need to be sourced somewhere, and you can have this binary decision for each of the parts. Of course, if you're assembling a car and you're not constrained because there's no rules of origins, for instance, you're going to pick the location for each of those parts that is the lowest cost. So you're going to minimize this thing. If we're gonna in what follows, we're gonna assume that those costs are distributed with type 1 extreme value, which will have the convenient feature of giving us a directly estimable functional form for the discrete choice. Okay, so this for now, let's say that there's a mean cost of 1 in home and a mean cost of delta in the forest. Okay, so this delta, if it's under 1, the foreign country has an advantage; it's least costly. And if it's above 1, the foreign country is more costly. Note that this delta is also indexing the quality, the productivity of the firm, the cost of the firm. That is, the higher the delta, both the higher the cost, and also the higher you have a cost foreign, the higher you want to, the larger share you want to source at home. So there's essentially going to be 2 types of costs to be considered in that model. The first one you see here at the bottom of that slide is called CU of delta. So it's U is for unconstrained. And so we want to compare the unconstrained choice, what the firm would do if it would be unconstrained, and to the situation where it's constrained by the rules of origins. In this unconstrained choice, you're gonna choose here it's very, very simple, because the cost is 1. You see this 1 at the numerator and this 1 at the denominator. That's the cost of sourcing at home. And delta to the minus theta is just the cost of sourcing abroad. And so the probability is just this 1 over 1 plus delta to the minus theta, which is the share of parts that you're gonna source at home, because 1 is at the numerator. Then you can calculate using the Eaton and Corton technology, which is very simple here. You can calculate the total cost of parts, the expected total cost of parts if you're unconstrained. And that's just this share. So the share of domestic parts raised to a certain power. So it's really extremely, extremely simple. That's for the unconstrained. Now, if you're constrained, you're gonna have to comply with rules of origin, and this rule of origin is this X here, X of R. R is for restricted. You're gonna have to meet, if you want to pay zero tariff when, again, exporting a car from Mexico to the US, you're gonna have to meet that rules of origin, and that is a certain percentage. It's like imposing a tariff on inputs, because the higher the tariff, the more you're going to have to, you're going to be incited to actually source within NAFTA and not outside of NAFTA. But it's not quite like a tariff, because there's actually not paying a tariff. It's so you can actually resolve that optimal tariff without paying it and get to that cost. You see, it's cost of XR delta, which is the cost of a firm that is constrained, that complies exactly with the rules of origin, let's say 62%. And this cost, expected cost, depends, of course, on its delta, because it's more costly to comply if you have a low delta, because that means that you are distorted away from your optimal allocation. Let me show you a graph just to show you how this thing works, and it's going to be quite trivial. So this is the cost penalty. So this is the ratio of the constrained cost to the unconstrained cost. So the cost penalty of complying to rules of origin is something that forces you to buy more parts that you would do optimally inside the region. So if you're a firm, let's say this green firm here, this green firm is a delta 0.8. So this green firm has actually would normally be inclined to have lower cost outside of NAFTA. Let's say it's a Japanese manufacturer, let's say it's a Chinese manufacturer, Korean manufacturer, or a German based manufacturer. It has a lot of good alternative to source its engines and transmissions outside of NAFTA. Therefore, its delta is 0.8, it's under 1. If the regional content requirement that you see on the x-axis is very low, it's unconstrained. The cost penalty is 1 because the ratio is 1. It has no cost penalty because it doesn't need to actually buy anything from NAFTA in order to comply. But as you see, it goes from 0.2, 0.4, 0.5. You see that this green curve is increasing, and at some points, the cost penalty is crossing this tau, which is the tariff that is imposed on a car that would not comply, that does not meet the rules of origins requirements. And you see this convex shape here is general. So this is for the green firm, this is an orange firm, this is a blue firm. It just depends on what is your natural tendency to source from within NAFTA. That is probably your natural base of different parts in your value chain that you would find optimal, everything else equal, to source from NAFTA. So this blue firm at delta equals 1.2 is a firm that finds it actually very good and very easy and very cheap to source from NAFTA. So it's less constrained. So you see its cost is still increasing, but it's increasing at a much later than this green firm. Okay, so this is the same graph at the top, and at the bottom of that graph, you can see the optimal choice, what this on the same axis between 0 and 1, that's what NAFTA imposes. You can see what is going to be the optimal thing to do for cost minimization for each of those 3 firms. Okay, I show you 3 firms here, which is, of course, not only a numerical example. The green one first is going to, of course, buy 0.3%, which means that 30% of its part is going to be in NAFTA. That's optimal for it once for low XR, and then at about 0.3%, it's going to be constrained. So you see this 45-degree line here means that it's actually choosing to comply. So this thing on the y-axis is exactly equal to the x-axis, so it chooses to comply. And at some point here that you can see, which is exactly this point there, the cost of complying goes above the tariff, and it's it's not meaningful anymore. It's not cost efficient anymore to comply. And so the firm drops immediately and quits compliance and becomes a non-complier, in the sense that it prefers to pay the tariff on the final car rather than pay the additional cost of having bad sourcing, in a sense, having inefficient sourcing imposed by the rules of origins of NAFTA. So this is the green firm. It drops pretty early, and the orange firm drops later, and the blue firm drops very late, actually around 1, to its optimal level. So you see, there's this discrete optimal choice of the firm, that each of them first complies and then drops and gets back to its original optimal choice by saying, forget it. I don't want to buy 70 or 80 or 90% of my parts inside NAFTA. That's too costly for me. I prefer to pay the 2% or 10% or etc. tariff, sometimes 25% on pickup truck tariff to sell it inside the US. So let me go directly to another graph, just to show you very fast, so that I can go, because I see that we're a little bit late on schedule. Show you this graph. We say there's 3 different types of firms. So let me show you first this graph. So you see on the x-axis here, you have the firm level cost advantage. So a firm that is very low here is the firm that has a very strong advantage of sourcing outside of NAFTA. And a firm that is on the right of this x-axis is a firm that has a very strong advantage of sourcing inside NAFTA. Let's say GM, Ford have a lot of really good plants inside NAFTA, so they don't care that much about the constraint imposed by NAFTA, because they have good choices inside NAFTA. So they're compliant, unconstrained. They would comply, even they do comply because that's their optimal choice. They have such good choices inside NAFTA that they source everything from within NAFTA, and that's not a constraint for them. On the opposite, some firms, let's say BMW, have some choices inside NAFTA, but don't have such great choices, because they turn out to have really good choices for their engines and transmissions inside the European Union, which of course doesn't enter the requirement for NAFTA. So they're non-compliant. Those firms are going to actually choose not to comply because it's too costly. In the middle are the firms that are have some good choice, some worse choice, and they're going to be constrained in the sense that they're going to find it optimal to actually comply, even if it's costly for them. And that's, in a sense, between this delta star and this delta naught, that's the target of the rules of origins. That's trying to push some firms to actually comply and raise their local content in order to raise local employment and local set of firms. Those 3 populations of firms, at first, when again the rules of origins are not very constrained, of course, the first thing is that nobody is really constrained because everybody can actually abide to a 0% thing. And then you see that green population falls down, because when you go up to 100% of compliance, only a very, very few set of firms would actually comply with 100% rules of origins. And so as you see this orange curve here now is the population which the rules of origins are actually targeting, trying to constrain those firms to be complying more than they would naturally. And the non-compliance is what's going to constitute the declining parts of the Laffer curve, which is those firms that actually drop out at some point, decide they don't want to comply anymore, this is too much. And so we can show in this theory that there's a Laffer curve where you see this let's focus on this orange line here. This is the outcome, actually, if you raised your regional content requirement within NAFTA, let's say from 40 to 60%, that's going to increase the regional content share of firms, because more of the population of those constrained compliers are going to actually comply. And at some point, it becomes too much. At, let's say, 75% here or 80%. Now you're on the downward part of the Laffer curve. If you still increase this rules of origin prerequisites, you're going to actually have more firms that leave, in a sense, that stop sourcing from NAFTA or even stop locating in NAFTA and decide to actually build the car in Japan or Germany in order to sell it to the US. So that's the type of decision we have, and we're going to investigate that in the empirics. Let me jump directly in the empirics, where we plan to estimate parameters of this model in order to see which side of the curves we are in, for instance, within NAFTA. Or another good example is Brexit, where the UK, which used to be, of course, inside the customs union, had no rules of origin, but now will face rules of origins for its cars. It's going to be a big deal for the UK, which has a lot of car production. Okay, so what we have is data from a consulting company named IHS Markit, and it tells us essentially two pieces of information. First, we know which plants each engine and transmission that gets into each car assembled in every single plant in the world, almost every single plant in the world, 95%, is produced. So we know that the engine that gets into a diesel Beetle produced in Puebla in Mexico comes from, let's say, Győr, Hungary. So it's a precise plant that is in Hungary. Or some of those Beetles actually get some engines from this same factory in Mexico, and some of them get them from another place. Same thing for the transmission, and that's the first piece of information. The second piece of information that we know is where those Beetles are sold. Starting from this plant in Puebla, we know which part of it is sold in the US, which part is sold in Mexico, etc. So that's completely new data to our knowledge, in the sense that academically used. A really interesting thing is that in-house means here inside the firm, a huge majority of engines are made by firms, assemblers themselves. Only 70% for transmission, is still pretty big. It's 80% for engine and 53% for EU engines and transmissions. Also, engines are really produced much closer to the final car assembly than a transmission that travel quite a lot. Actually, Japan is a big producer of transmissions for the rest of the world, which I'm going to show you in a minute. Okay, so what we're going to do is look at. Let me show you a typical example of what we're going to do first graphically, and then with some nice pictures. So we're going to first look at the choice of an IK. We call it tuple. So it's like choosing I for the engine as a plant, choosing K for transmission as a plant, conditional on sending this engine and transmission to a given L, which is a plant where the car is assembled. So the global value chain is that you choose an engine and a transmission sourcing, so a couple of engine and transmission plants, send it to the vehicle assembly plant, and then send the vehicle to the market. So that's our chain of decision. And each time you're gonna source from the best possible location, both engine, transmission, and the final car. Okay, so let's take an example. This is I was telling you about the Beetle. This car is produced only in Puebla, so it's really simple. It's produced in Puebla, Mexico, and it's sold everywhere in the world from this plant. But this car is based on a platform. Okay, so this is an example of a platform, another Volkswagen platform. A picture of actually the platform, the next generation after the Beetle, but it doesn't matter here. And you see this platform is used actually in a, you see 1, 2, 3, 4, 5, 6, 7, 8, 9 different models of the Volkswagen group are based on the same underlying platform. So what we're gonna assume is that in order to produce the Beetle, you need this platform. In order to source an engine and transmission, you need this engine and transmission to fit within that platform. And therefore, we're gonna show you a little graph here, which is this engine and the underlying transmission have to come from a plant that is already producing or has produced at some point engines and transmission for that given platform. So that's the choice set in a sense. You see that this is Puebla, Mexico, where the Beetle is assembled. It can have a diesel or gas engine coming from Shanghai, Silao, Ogior, as I was mentioning. There's actually 13 different plants, 5 of it in China, that could produce engine that fit within that PQ35 platform. And in transmission, we have Shanghai factory, Barcelona factory, Anzhou in Japan, Okazaki in Japan, that actually produces transmission that go into that platform also. Okay, so 8 different plants are among the actual choices. And if you want to serve, let's say, France or USA from this Puebla factory, that's not the only possibility. This Beetle could come from any of the other plants that actually produces PQ35, let's say the Golf or the ODA3, which is based on the same platform. Okay, this Beetle could be done in Poznan. It could be done in Chattanooga, Tennessee. It could be done in Nanjing in China for those different markets. So that's our chain of analysis. We're gonna actually try to estimate. So it's a big data set. We have over 100,000 vehicle specification chooser. So a vehicle is a Beetle. The specification is a automatic gas, a horsepower of 120, a Beetle. That's a vehicle spec. That's our chooser. They look for an engine. They look for a transmission, a couple of engine transmission. And so that's about 4 million observation, okay? And that's one choice. Then the vehicle sourcing is going to be 3 million observation, because I'm buying from France, I'm buying the Beetle from Puebla, but I could buy it, as I showed you, from 6, 7, 8 different plants actually that produce this platform. And that's another big set of observation. We estimate this sequentially using Poisson pseudo-maximum likelihood, which is a much faster estimation method than the multinomial logit estimator, but the basics is multinomial logit. I'm not going to show you, for the interest of time, the equations of what we are estimating. I'll show you results. But the basics is a nested logit. You choose first, let me show you back here. You choose an assembly for your vehicle. You choose Puebla to produce the Beetle when you sell it in that given market. And then you choose an engine and transmission tuple. That's a nested logit, and you see that chain is that the probability of observing your Hungary and a given transmission plant selling to Puebla when this car is sold in the US is the product of those two probabilities, which, for those of you familiar with nested logit, is quite simple. So let me now show you. So there's 2 stages, and I'm going to show you now a set of results in the 10 minutes I have. I want to show you a number of and highlight a number of important results and introduce you to the potential counterfactual that we're going to do in the future. I should have said that that this is very, very much ongoing work, and very much in progress, but this is where we are now. So this is the stage one. Stage one is in the tree, it's the last thing, but in the estimation, it's the first. So you have a nested logit, which is like a sequential choice, and so you solve it backwards. So you first look at the optimal engine and transmission choice, and once you've estimated those engine and transmission choices, you estimate you have actually an estimate of the expected cost of an engine and transmission, and you plug in that expected cost of an engine and transmission in the assembly decision, the upper level choice. So in the lower level decision, we have a number of determinants here that you see the distance of the engine and transmission plant to the V plant, which is the assembly. So here it's, for instance, Hungary to Mexico, China to Mexico, Japan to Mexico, because each of those choices for engines and transmissions are possible. So you're looking at the actual choices and estimate the impact of this log distance on the choice. And you see that both for engines and transmission, this is a quite strong deterring effect of distance. The engines and transmission don't travel very well to the plants where they are assembled. It's, as I mentioned, it's worse for engine than for transmission. So that's the first fact. Same firm is whether you produce this engine in a firm that belongs to the assembler. You see, it's very strong for engine, not at all for transmission. That's really quite a big difference. Those engines are made in-house. You know, Renault makes the Renault engine, most of it, and GM makes the GM engine, most of it. But they buy their transmission from French and Austrian and Japanese and Chinese company. This is an after effect. Of course, it's very strong. EU effect is very strong and positive also. And actually, all RTAs are very strong and positive. So a lot of the engines and transmissions are actually sourced within the same regional agreements, which is expected. The most important parameters that we have here, well, there's those two parameters here, is the impact of tariffs. So what is really good with the car industry is not only that the data is excellent. So this is 20 years of data, by the way, from 2000 to 2018. So we have a lot of time and a lot of cross-section choices, as I mentioned, but we also have a lot of variance in the tariffs, both at the part level and the car level. There's really a huge variance over space and over time in the tariff, which enables us to have those very well-estimated part tariff elasticities and car tariff elasticities, which is going to help us estimate those structural parameters of the model when they're going to be so useful when we simulate policy choices. So that's for engines and transmissions. There's actually a set of fixed effects in this structural estimation that tells you how good is each country in each part. So this is the engine in blue, and you can see that compared to the US, which is normalized at 1, you can calculate the % difference in cost in engines and transmissions. So you can see, as I was telling you, that Japan here is a very low cost or revealed cost in terms of transmissions and engines. And you can see Hungary is one of the most efficient producers of engines. Germany is also very efficient at producing transmission. On the other side of the spectrum, China and India and Malaysia are really high costs when talking about sourcing of engines and transmissions, which essentially means that the only engines and transmissions that they do manage to sell to a plant, an assembly plant, are their own plants or plants that are really very nearby and most of the time within the same country. When we have those estimated costs, we can plug them into this stage 2, which is the vehicle assembly sourcing. So here it's the same story, but instead of choosing a plant for an engine and transmission, the firm is actually choosing a plant for the assembly of the car. So the final stage before selling to the consumer. So here you can see a lot of things. First, again, a very strong impact of distance, a very strong impact of crossing a national border, which is telling you that most of the cars are actually sold within national borders, you can see, of course, strong regional effects. And again, you can see the tariff. So, for instance, the EU countries within the EU, the tariff is, of course, 0. With the set of countries for which the EU has an RTA, like South Korea, like Japan, like Mexico, there's no tariff. But when a car comes from the US or from China, it has a 10% tariff. So you can actually estimate those tariff elasticities, and those turn out to be around -5, which is really a strong effect. And another thing that you see in those columns 3 and 4, which I don't have a lot of time to detail, but just let me tell you, is that this last variable is the inclusive value, which is telling you the expected cost of an engine and transmission for this precise car, which is coming from the stage 1 of the estimation, which reveals us the expected cost of an engine and transmission, how this assembly plant is well located in order to source engines and transmissions. And that has a strikingly similar, this is a cost, so this is really a little bit like a tariff, actually, in spirit, and this really has very close by estimates. This is the same thing as I showed you before, the estimated revealed cost of assembly now, the final car, and you can see that again. We can see old producers of cars and some new producers of cars, like of course. You can see Germany, you see Britain, France, you can see Japan here, you can see Korea, Turkey, and Hungary and Slovenia. And on the other side of the spectrum, you see China, you see Venezuela, of course, Taiwan, Iran, are countries that mostly assemble cars for themselves, don't sell them far abroad.
Excuse me, Thierry, you have 1 minute left to finish.
Oh, sorry. So let me just finish on this slide and give you an idea of what we do next. The counterfactuals that we are going to do to connect the theory with the empirics is the following thing. Consider Toyota making Toyota Corollas in Canada. They could comply and source a transmission for the USA instead of Japan, which is actually what they're doing now. Or they could not comply and pay the 2.5% most favored nation tariff on the Corollas sold in the US. Or they could relocate the assembly of the Corollas for the American market to Japan. Those are the 3 things when Trump actually raises the compliance level to 75%. Our estimates are going to be making us able to compute what is the optimal strategy for each of those cars sold in the US. So we're going to see whether we're on the right side, on the wrong side. And the first pass of what we're doing is that we're estimating this cost penalty for a radical option where they would be forced to produce both engines and transmission within NAFTA, and for some producers like Daimler and Toyota, it's like 6% of the cost. So that's giving us an idea of how costly those rules of origins are. Let me stop here. Sorry for going a little bit over time. Thank you.
Okay, thank you very much, Thierry, for presenting this very rich and interesting paper. Unfortunately, we don't have time, so we will conclude this session for now, and you will receive the questions later, and we will have the time to discuss about that later. Thank you very much. See you then. Merci.